Well, good afternoon. I got to tell you, coming to a session during the lunch hour puts a little bit of pressure on me because I feel like you really want to know about Windows Hello, and if you're going to miss your lunch for it, then I need to deliver. Maybe if I throw out sandwiches or something, it'll make it better. So my name is Jeff Burtoft. I'm a principal program manager at Microsoft inside of the Windows group, a group called Partner App Evangelism. I have 3 kids and a beautiful wife who is not in this picture. She says it's because she's always taking the picture, but I think she just doesn't want to be associated with us. And that is not how we dress for work. As a true Microsoftie, the only time I ever wear a suit is when it's like a funeral or wedding. So, but having 3 kids, I do a lot of dad jokes, so you're going to have to put up with that today. So we're going to talk about Windows Hello, and we're going to talk about auth, and we're going to start out talking about what's wrong with the world today. And then after about 3 hours, we should be able to move on to, the real stuff. Now, but we're going to talk about auth because it's important to start out and help understand what we're thinking about at Microsoft when we invest so much research and time and development into Windows Hello and some of the other authentication scenarios that we have. So basically the world sucks today, right? Every time we turn around, we're seeing some other breach of security on the news. Recently in the US, Equifax, who has all of our information, they know everything about me, including my social security number and my driver's license. They lost it all. It's a scary world to be in. You think about even things like the Yahoo breach, and just a few days ago, I think they came out and finally said that they lost everybody's account data. It wasn't just a certain group. They found out that they had lost everyone's. But if you think about Yahoo, who is an account provider for other websites and other companies, and maybe even some of us in the room, or at least at one point, it starts to get a little scary about how we're going to work in the future to make sure that we can keep our customers and our users secure. So one of the big problems with security is passwords. So we know that 76% of data breaches happen through the use of a password that was obtained. And multi-factor certainly helps, but what we find is that users don't like to use multi-factor. It adds additional steps. It makes the authentication process harder, not easier. So we don't think that that's going to be the final solution that we're looking for. Now, while all of this is happening, the world is changing around us. We're trying to make things more secure, but yet our world that we need to secure is changing even more and more. So devices are prevalent in the workplace. It used to be that we would worry about just securing a PC, but now we have to worry about how a user's phone is also secure. Software is being delivered now as a service on a device, so it's not as easy as just installing a disk as it was in the past. Now we have to worry about keeping connections to security software and making sure that that is continuously authenticated. And where and how employees work is changing as well. A user doesn't always sit in front of their computer. They're not always sitting at their desk. They're not always working inside of an office. So that's changing, and it makes it even more difficult for us to secure the world. So we've come out and stated that we think the solution is going to be to continue to change. I don't think that anything that we provide today we think is going to be the answer forever, but we want to continuously make steps in the right direction and make sure that we're always ahead of where the people who are trying to do harm to us and our users are. And the first step is getting rid of the password and trying to do it in a way that works for users, that makes life easier for them instead of harder for them. So one of the first steps that you want to think about as a developer is when you are authenticating, how are you going to do that with your users? How much responsibility do you want to have to collect usernames and passwords and make sure that that data is secure? So the very first thing that when I'm talking about authentication that I recommend to people, when you're building a Windows app, use the Web Account Manager. And what that does is it gives you the ability, first of all, to connect to an MSA. If you're looking for a way to authenticate your users inside of your Windows application and you don't need or are tied in with an authentication system, use the MSA that's already on the device. When the users are logged in with their MSA, it becomes a very transparent experience for them, and they're able to then authenticate with your application a lot more often because it's already going to be authenticated. You're not going to have to reprompt them for usernames and passwords. You can also tie in with third-party authentications like Facebook's or other apps that the user may have installed on their system that will act as an authenticator. So if they have the Facebook app already installed, you're using Facebook for authentication, the Web Account Manager will allow that to bring up the system dialog for them to choose their Facebook account to do the OAuth for you instead of you having to write the flow yourself. And of course, if you're using a provider that doesn't support the Web Account Manager, such as Twitter or Google+, you can manually add that in so that the user can use the system flow to authenticate instead of, again, writing out your own OAuth flow. So it's a very good place to start. We're still dealing with usernames, we're still dealing with passwords, but it gives you the ability to take advantage of authentication that has already happened on the device instead of creating a new experience for yourself. So throughout this deck, I have some links here, and we'll provide it afterwards because I'm sure it's difficult to collect all those at once. But there's plenty of more information about implementing the Web Account Manager out on MSDN and the docs.microsoft.com. Okay, now let's start talking about a world without a password. Now, what Windows Hello does for us is Windows Hello is a mechanism to access a secure TPM on the device. Okay, so there's a secure store for you as a developer to be able to use. And what it does is instead of requiring a password to be able to access that store, it uses the Windows Hello authentication. Now, Windows Hello authentication involves a number of different aspects. It is PIN by base, biometric authentication, and companion devices as well, which we'll talk about in a few moments. So this is how it works. You start with a user, and the user wants to load up an application. All right, now that application wants to access some secure data. In this scenario, let's just say that that is a private key. So the private key has been stored on the TPM chip on the device, and if there is not a TPM, then we do have a software version of the TPM that is secured as well. And to be able to access that TPM, it has to go through Windows Hello. So Windows Hello is then a system prompt that will pop up and ask the user to authenticate. Now, when you think about that, so Windows Hello is a single authentication for the user on that device. So if you have one user in multiple devices, they have to register with Windows Hello on each of those devices. If you have multiple users in a single device, then each of those users have to have their own account to use Windows Hello. okay? But they only have to do it once. They don't have to re-register Windows Hello every time an app or a website wants to utilize it. So they do the system registry, they then validate that they are who they are, and then that application is granted access to the secure store on the TPM chip where they can retrieve the sensitive data, send it off to a website, or do whatever processing they want to do with it on the client, and then return the data back to the user. When you look at this a little bit deeper, there's two things you need to consider here. First of all, Windows Hello gives you the ability to authenticate in multiple ways. So I talked a little bit about it already, but a user can choose which of these methods that they want to support. So they can say, I'm going to support PIN and biometrics, or I'm going to support multiple forms of biometrics, or I'm going to have a companion device with biometrics. When they're prompted for that, they can then choose which one. There's a default setting. You as a developer can get data back to know which one they're using and limit the type of gesture that they use. But by default, they get to choose how they're going to access their device. So you can think about it in a scenario if they're using a Windows Hello device and it's super bright sunlight outside, they're in direct sunlight, and they're having a hard time authenticating, they likely are going to want to switch over to a PIN or to a fingerprint reader instead to be able to use it in that scenario. Now in the TPM chip, we're going to talk in a few minutes about FIDO and how FIDO works by storing a private key inside of this store. But you as a developer can actually store anything in there, okay? Whenever your application requests access to this secure store, you can store whatever you want. You can store a password in there if you like, and we actually call that password stuffing. So if you are just working through traditional login with a username and a password, and you want to be able to securely store the password for your user so that they don't have to be prompted for it every time, you can actually put it in here. You can store the password in there, and then whenever access is granted, you take the password out and you use that to submit the authentication flow. Now, granted, that does not help save the problem that we have with passwords, because you're still then transmitting secure data back and forth between a server and a client, but at least it gives you a way to be able to protect that with the Windows Hello and biometrics to be able to get a experience that is better for your users, but still just as safe as if they typed in the password themselves. Now, by default, having a use of Windows Hello is a two-factor experience. So the Windows Hello provides you multiple things. First of all, it provides you a biometric. So that's kind of a who you are or a what you know type of scenario as one factor. And then the device itself that is registered is a second factor. So I mentioned earlier, you can't reuse a login from one device to another. Each device has to be registered separately. You can't transport data from a TPM on one device to data on a TPM on another device. So when you request the access to the TPM and the secure data inside of that, you also can get an attestation key that identifies the hardware that's being used. So now you have two ways that you can identify the user there by using Windows Hello. Now we do have a new addition to the Windows Hello family. In addition to the PIN and the biometrics, we have companion devices. Okay, and we release a companion device framework for you as developers to be able to use this as well. Now, the companion device, if you think about what that would look like, first of all, it's something that you use with Windows 10, with Windows Hello. It's not a separate flow for you as a developer. When you support Windows Hello, you're supporting the companion devices as well. It gives you an opportunity to provide Windows Hello experience for users that may not have the hardware. So they may not have one of these beautiful devices up here with a Windows Hello camera. They may not have a fingerprint reader, although those are becoming more and more prevalent, but they may have a device that's supported. So for example, they may have a phone that they're carrying with them. The phone may be a companion device or may have an app on it that, once paired with your PC, can then be used as a companion device for Windows Hello. So there's a number of scenarios that can be supported in a companion device. It can be something like a device that is attached, or it can be tapped onto a NFC on your PC, a card reader type of scenario. It could be a phone that the user has in their pocket, and maybe the phone and you as a developer can determine the type of security level that you want to support. So for example, with a phone, just having the phone within distance of the PC can be either a ability to unlock it, or maybe a factor in the ability to unlock it. Or you may have an app that you use, like a authenticator app on the PC, where the user can then touch their fingerprint to the phone, or use a pin on the phone by unlocking the phone to be able to then authenticate with your PC. Or it may be something like a fitness band that is authenticated to the user when it's on, and then when it comes within proximity of the device can unlock. So this plugs right into Windows Hello system there. You don't actually have to write any special scenarios for it. Again, as a user, whenever they go to use Windows Hello, a companion device, if registered, configured, supported in that scenario, can then be used as one of the ways for them to authenticate with Windows Hello. We have a number of people who are out there building these companion devices, and we're seeing a lot of interest in them, especially in the enterprise space, where keeping PCs secure themselves is very important. And one of the features that comes along with this is dynamic lock. So basically, the ability for your PC to lock itself. There is a lot of scenarios, especially in the workplace, where you may not want to leave a PC authenticated without the user around it. You can imagine a scenario where there's a manager who has access to systems that other people don't, and leaving it alone may make it insecure. It can be used with Bluetooth connection to the device itself, or it can be added as a companion device. So you can register your phone on a PC. So there's one big scenario that drives this. This is a cartoon that I found in one of the Windows Hello blog posts, and I might have done a little bit of editing to make the story a little bit more interesting. But there's Ted, and Ted decides that he wants to go for coffee. And then we have Ted's friend, with air quotes, who tries to access Ted's PC while he's away. And I'm sure this has never happened to any of us. And of course, Ted's PC is secured automatically because of his companion device. And then Ted is saved even while he's having coffee. So it's a really important scenario for the workplace where you have a lot of people working in proximity. And I'm sure none of us have friends like this. You may know friends who have friends like this. Maybe you're the friend. Okay, again, there's a number of articles out there that we have on supporting the companion device. This is where it gets good, in my opinion. Windows Hello is fabulous, and it is very convenient, and I love it for authenticating with my PC. But what you can do with it in the FIDO 2.0 area is where it gets really interesting, because this is where we get into the space where passwords can disappear. Okay, so FIDO stands for Fast ID Online. It's kind of a weird scenario, but basically a lot of people who think auth is really important, Microsoft is among them, got together and said, hey, how are we going to make systems more secure in the future? How can we get away from the passwords and the increasingly complex passwords, which then forces us as users to rely on password managers, which then become larger targets for hackers to attack. And they came up with a system that they call FIDO. So there's a few steps to using FIDO. And the first step is to actually be enrolled in Windows Hello. So if you are trying to utilize FIDO, then the first thing that you need to do is make sure that your users are actually authenticated with Windows Hello. And this is because you're going to need that secure store to store data into. The next thing that you're going to do is you're going to have a back and forth between a client and a server where neither of them have to transport secure data back and forth. Okay, so the first thing, so actually I don't have I'll go over in a minute what the flow for registering with a FIDO with a FIDO server looks like, but this is what the flow happens whenever you are authenticating with that. Okay, so FIDO requires two parts. It requires a FIDO server to handle the authentication, and this is basically just a spec. It doesn't have to be a special type of server. Many of the partners that we're working with are building this themselves. There's just a couple conditions that it has to be able to handle. And then you need a client. So step one is I request authentication from my server. Okay, and let's just say this is my bank. And I'm going to go and ask my bank to authenticate me. Well, my bank is then going to, and maybe I send them my username, okay? And then my bank is going to then send me a challenge. So this challenge can be anything. It can be a piece of text. It can be something that changes, or it can be something that stays the same. Most of the times when banks implement this, they have a rolling challenge that is issued uniquely for every user. But it's basically a string, okay? It's a string of text that's passed down to the client. And then the client will then sign that challenge with a private key. And where do they get that private key? That private key is stored inside of the TPM that they use Windows Hello to get to. Okay, so I have this challenge, and then you as a developer will then call a function that will give you access to the private key. When you have access to that private key, you will then sign this challenge, and you'll send it back up to the server. And then the server, during the registration process, has been given your public key. And then if they can unsign that challenge with your public key, and they match that challenge and know it's the same thing that they sent to you, then you're authenticated. And the great part about this is that there hasn't been any secure data that has gone back and forth. On the client is where the private key is secured behind Windows Hello. And on the server, all they have are public keys. The public key is no good without a private key. There's no point in trying to store public keys, because without a private key, all you can do is verify that that's the person who that you sent the challenge to. And if for some reason the public keys are accessed, you can just expire them and then re-register everyone. Okay? Code-wise, this is actually quite simple I shouldn't say quite simple, because it's just a few lines of code to implement, put it that way. Step one is to create a key. All right, so the first thing that you're going to do is when you are authenticated with your server, they send a challenge down to you. If you don't already have a key, the first thing that you do is you create a key. So you will call the key credential, this step is to see if it's supported, and then you call the key credential to create a key. And then they give you two parts of it. One is the private part that goes right into the TPM chip, and the other one is the public part that you send up to the server. So now they have your public key, you have the private key. Every time that a challenge is sent, you pass the challenge into the key credential manager. It will then prompt Windows Hello, which gives them access to the key, which they then sign that challenge with that private key and return it back to you. And then once you get it back, you send it up to the server, and then the server knows that it's you. As a user, this might be what it looks like. Okay, the user wants to log into their Woodgrove bank. So normally they go in and they sign in with their username and password. So then the bank knows this is my user. This was our traditional way for me to authenticate the user is who he says. And then they present the user an opportunity to enroll in Windows Hello. Now the first thing that the bank had to do was test to see if they were already authenticated with Windows Hello. If not, they send them to a flow where Windows itself will then sign them up with Windows Hello, do a facial scan, get a PIN number, and then they are prompted with authentication. So let's say they use their fingerprint now to log in with Windows Hello. This is now when that key is created. They will store that public key, store that private key, pass up that public key, and then they're logged in. Now the next time that you go to log into this account, you'll see that you're prompted with the ability to log in with Windows Hello. That same system interface pops up for the user to then give their authentication, and then in the background, you as a developer are working to get that challenge, sign it, and return it back to the server so that they know that user is an authenticated user. So for a user, it's a very simple process. They don't have to remember anything. They don't have to do any type of two-factor authentication because Windows Hello, first of all, is multi-factor by design. And second of all, the system itself knows who the user is, and so it's able to authenticate on their behalf using Windows Hello and biometrics. Now, I think the best part about this scenario is where the risk is removed from. Today, if you think about the scenarios with like Yahoo, where Yahoo was a very large target for a hacker to break into their authentication system and get access to millions and hundreds of millions of users' info. So it became a very attractive target for a hacker. If you think about this scenario where the risk is removed from the server, where the only thing that's stored in the server are public keys, it's moved on to the client, where that's where the private keys are secured. They're secured, they're encrypted, protected by biometrics. So now if a hacker wants to get 100 million accounts to access, it potentially would have to hack 100 million different systems. So now the risk has been translated from a very popular target where they may be trying to target a server or trying to target the HTTP traffic that's going back and forth. None of that now has any value, and so the only target that's left is the client itself, which means they would have to hack every individual target to be able to get that type of data. So now the risk-reward scenario for those hackers just doesn't make sense. So those are the APIs that you use if you're building for a client. I showed the XAML version the C# version of those APIs if you're building a XAML app. If you're building a JavaScript app, you actually have those same APIs available for you. But we also have a web standard version of this interface. It was originally called the FIDO 2.0 web implementation. They've since renamed it to Web AuthN or Web. I think there's another class of the spec called web authentication, APIs. But Web AuthN has that same ability to reduce and remove the need of a password. So again, with Web AuthN, you have the same scenarios, and there's one scenario that I didn't put on here, which is to unregister, which is simply just a call that you can make to the system at any point to say this user is unregistered. And then the private key will be deleted from the TPM. It'll send a request up to the server to remove the public key, and if the user wants to re-enroll, it's like starting from fresh. But there's two different flows that a user has to go through here. First thing that they're going to do is feature detect to see if the Web AuthN API is available. Now, we are proud to be a leader in this space. When you're a leader, you often get to the finish line first. And so we have implemented both a prefixed version of Web AuthN that you can use today and a near final version of the spec that is behind a flag in the Edge browser as well. Now, the great thing is that if you implement this today, you not only get Edge users who are going to be able to utilize it, but very soon you'll have Firefox and Safari and Chrome users who are going to be able to use this as well. As they've joined the spec, they're building them into the different channels of the browsers at this point now. So you're feature detecting. You always want to start out and make sure that the API is there before you call it. And then the user wants to use passwordless, or what we call in our scenario, the Windows Hello login with a server. So it calls the make credential. All right, so this is the registration process that I talked about with the C# flow. Make credential, you pass in user account information. So this associates you with a user account and a domain. The crypto parameters, the challenge that you want to have signed, and then any options such as encryption level. So your user account information is up to you as the developer, the information that you want to include there. This is going to be stored with the key, identified with the attestation that you get from the machine. Your crypto parameters are something that you create and pass in. It tells the level of the crypto that you want to utilize. The challenge, again, is just like it was in the FIDO C# example. This is just a string, a text string. And then the options can have a timeout, and it can have an include or an exclude list. So if you want to say this is Outlook.com, or this is for everybody but Google.com, or something like that. And then once you're registered, you then request to be authenticated. And this API is called get assertion, and you're simply passing in the challenge and the options. So remember, at this point, you're getting a challenge from the server. It's a text string, and you're going to want to return that to them signed with your private key. So you call in this method, pass in the challenge, and then you wait for it to do its magic. And of course, what's happening in the background is this is what a challenge looks like, the options. What's happening in the background is it is then sending the challenge back down, which prompts the Windows Hello. And when Windows Hello knows that it's you, that you entered your PIN, or you have your device, or you use biometrics, it will then go ahead and sign the challenge and then return the challenge back to the server. When that server, which is also a FIDO server, it's the same server that you would use if you're doing it inside of a client, we can unsign that with the public key, then they know it's you and you're authenticated. Okay, let's see what this looks like. And this is actually a sample that is out there today. So if you have a Windows Hello device, you can check it out. All right, so this is my make-believe bank website. My name is John Doe, as you can see by the screen, and I'm going to log in. I can sign in with the password. Oh, actually, let's reset this. Okay, so the first time I'm going to do is I'm going to log in with my password. All right, this is the typical authentication. And remember, when you're setting this up, you always want to start from an authenticated position. So there has to be some point to start with where the server has already felt safe that it's talking with the right client. So in this case, if I'm using a password and a PIN number, or a password and a challenge, whatever it is that the authentication system or the bank wants to use to authenticate with me, they're going to do that. So in this case, it's the password. I'm going to log in. So they know it's me, and now they're going to ask me, they checked my system to know that I have Windows Hello. They're going to ask me if I want to do this, and I'm going to say yes. And then it's going to pop up. Ignore the fact that it gets an error the first time. That's my special version of Windows that us employees get the opportunity to run. If you think the fast ring is fast, you should see what we have. And then I am logged in, okay? So this is the authenticated version of the website. Now the next time I go to log in, it's going to actually have a button that I can click and authenticate. Now, one of the things that you notice is that this flow the UI is created entirely by the site. Okay? So you as a developer have complete control over what the flow looks like for your users to authenticate in this FIDO manner. Now, there is that one point that you'll see where you don't have control, and we do this on purpose because we don't want this to be something that can be spoofed. But this part right here happens it happens from the operating system itself. Okay? So this is something that is passed up to the operating system level to be authenticated, and then the result is passed back down. And you'll see I have two authentication points to choose from here. If I want to say that I only want to use the PIN in this scenario, then I enter my PIN, and it authenticates just as it did with the biometrics. So there's a few methods that you have to handle on the back end with a FIDO server running on the other end. If you go out to and I'll have this at the end here, the doc site for Web AuthN, you'll see we have a sample ASP.NET FIDO server set up. And it's really not that much code, but it's something pretty simple that if you wanted to implement your own FIDO server, you can clone that, make any changes that you need to, and put it in your environment. Okay, so as I mentioned before, there's a spec already out there that's almost final. We anticipate it being final before our RS4 release, which means that we will remove the flag then and have that fully accessible. If you want to try it out today for a trial or beta implementation, you can use what I just used, which is the prefixed version of the APIs. The big difference between the prefixed version and what the final spec will look like is there's a few additional APIs that are going to be added, like the attestation key will be added in the final version that isn't in there in the previously implemented one that we have. We've got a link to the spec here. You can go to, let's see here, it's status.microsoftedge.com, and you can see the status of not only where it is implemented on Microsoft, but where the other browser makers are in the implementation of it as well. And you can watch that and see everyone else implement it. And then we have a link here to some more talks about Web AuthN if you want to dig into that. So a few takeaways for you. When you're building an app or you're building a website, when possible, use the native auth channels. Okay? In an application, if you can use the MSA or another account that's already attached to the system, this doesn't just go for Windows. Whatever platform you're on, it's probably going to be a better experience for the user, and you're probably going to get a higher level of authentication and less secure data for you yourself to have to deal with. If you haven't tried Windows Hello on your device, I recommend that you do that today. If you don't have a Hello camera or a fingerprint reader, those accessories are available. We're starting to see them built into the Microsoft keyboards that we ship now, have a fingerprint reader built into them. You can also pick up fingerprint readers for pretty cheaply, for 10 or 15 euros that you can attach to your system. So try that out yourself and see how you experience it. As an app developer, please build in support for Windows Hello. We want it to be a Windows device to be a great experience for the users. So at the very minimum, if you're doing like a password stuffing scenario where you're just storing your password secure like you do on an iOS device, as a bare minimum, you should do that. Upgrading to a full passwordless environment is definitely the best and the future way to do that. And if you have any questions, you can reach out to me. I'm Boy of Green on Twitter, and you can find me in a number of places in the Microsoft sphere as well. So thank you so much for giving me your time over lunch today. I hope that you enjoy this session and the rest of the conference.